Alright, in this section we are going to look at arc lengths and sector areas. So the first thing that we need to do is look at just area and circumference of a circle. These should be review for you guys. Our formula for the area of a circle is pi times the radius squared. So we just have a very simple example to do here at first. So if I have a radius of 9 centimeters as indicated on the circle here, then to find the area, I just need to do pi times that radius squared, which will give me 81 times pi, or I can type this into Desmos, and 81 pi is going to be 254.469, 254.469, and that is going to be square centimeters there, because it's an area. Our other problem that we have on the same page is finding the circumference. That circumference is the distance around the edge of the circle, and to find circumference you can either use the equation 2 pi times the radius, or you can use the equation pi times diameter. In this case they give us, for example 2, that we are going to find the circumference of a circle with a diameter of 6 inches. So since they gave us diameter here, I would be more inclined just to use pi times diameter. So we would just have pi times 6. We can type that one into our calculator really quickly, and 6 times pi should give us 18.850. It's going to be 84955. It'll round up to 850. And that'll just be inches, not inches squared, because we're just talking about length here, so it's not square inches or cubic inches in that case. So, area of a circle, the circumference of a circle should be things that you have seen before. So when we talk about arc lengths and sectors, we'll be talking about a fraction of either one of these. So let's look at what we've got here. A sector is a section of a circle defined by a central angle and its corresponding arc. So over here in this picture that I have to the right, you can see that I have right here a central angle that is given, and then the corresponding arc that goes with it would be this orange arc that we see here. So this whole area, this whole slice of the circle right here is what we're talking about when we're talking about the sector. So we will need to be able to find the area of a sector. And the area of a sector is really just a fraction of the area of the circle. In a circle, we know that we have 360 total degrees. So notice here that the formula that we're given is A equals, this letter right here is a Greek letter that we use for angles a lot. It's called theta. And it very well could just be an x there. It's just a variable. And it is the measure of your central angle. Divided by 360 times pi r squared. Pi r squared should be very familiar. That's the area of a circle that we just found. So, if I want to find the area of the sector shown to the right here, then all I have to do for that area is I will do 150 degrees divided by 360 degrees, and multiply that by pi times the radius, which in this case is 2 squared. Right? So this is what fraction of the circle you're looking at. You have 150 degrees out of a total 360, so that's your fraction of the circle, and you just multiply it by the area. And if we type that into the calculator, then we should get 5.236, and that will be in yards squared there. So it's much like finding area, except we're just going to multiply it by this fraction right here. So I have an important question that we need to look at here. We have a group of friends is ordering pizzas. All pizzas will be cut into 8 slices. If the group orders medium pizzas, each person will get 4 slices. If they order large pizzas, each person will only get 3 slices. Which scenario results in each person getting the most pizza? So, in this case, if you get 4 slices of medium pizza, you're getting more slices, but the slices are going to be smaller. Whereas if you have 3 pieces of a large pizza, you're getting only 3 pieces, but the pieces will be larger. So, in this case, we would need to think about the area of the pizza that we would be looking at, and it's going to be like a sector area. Now, in this case, we're going to do it slightly different because they didn't give us any angles. But if we have medium pizza, then our area of the pizza that we'll be getting, we're going to get 4 slices out of the total pizza, and they're telling us all the pizzas are cut into 8 slices, so that would be 8 right here. So this time, rather than doing something out of 360, because we don't have the angle that we're given, we're doing 4 out of 8, 4 slices that we have out of 8 total for one pizza. And we would need to multiply this by pi times the radius squared. Now do notice over here on our picture, I see 12 inches and my ruler goes all the way across here. There are some mistakes in that picture because I made it with AI, so look out for those. But if I'm only looking for the radius, I would just have 6 right here. So pi times 6 squared. So if I type in 4/8 times pi times the radius squared, then I should get 56.549 cubic square inches. So with the medium pizza, I'd get 56.549 square inches. If we have the large pizzas instead, we would have only 3 out of 8 slices, but my radius would be 1 inch longer because a large has a radius of 7 inches. There. So if I type this into the calculator, I'm going to get 57.727 square inches. So in this particular case, you actually want to get the large pizzas. It's not a huge difference, but even though you're only getting 3 slices, you get a little bit more pizza if you order the larges there overall. Okay. We also need to know about arc length. So an arc is just we've already talked about arc, it's a piece of the outside of a circle. So for example, when we're looking for arc PQ here, we're just looking for the length of this outside piece, not the area of the whole thing colored in here. So you can see the formula for arc length here. It is theta, which still just refers to that central angle right there, over 360 times pi r squared. I'm sorry, I read that incorrectly. Pi times 2 times pi times radius there. We also could use the formula pi times diameter. Now you should be noticing that this is just a fraction of the circumference. So it's just a fraction times this formula here that's for circumference, or we could use this one instead if you prefer that for circumference. So if I'm trying to find the length of arc PQ for example 5, then I would just do, in this case, I will do 135 out of 360. That's the fraction of the circle that I'm looking at. I've got a central angle of 135 out of a total circle of 360. And then I multiply it by the circumference, which in this case can be found by doing 2 pi times the radius, which is 12. So if I type that in to the calculator, then I will get 28.274. And they don't put any units on this, so that could be inches, feet, meters, miles. We don't really know in this particular case. Okay, so let's reconsider the scenario from example 4. Let's say that the group is ordering stuffed crust pizza, and you really, 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 really love stuffed crust, and you now are only concerned with which option will provide you with more of that tasty cheese-filled crust. So all you care about is the crust here. Which option will be best in this scenario? 4 slices of a medium pizza or 3 slices of a large pizza? So now you don't really care about area. You want to know about arc length. Here, you want to know about what amount of crust you are going to get. So this will be similar to the last problem, but rather than being a fraction of our area, it's just going to be a fraction of our circumference. So for the medium pizzas, we will have, we get 4 out of still 8 slices per pizza here. And we will multiply that by, you can either use 2 pi times the radius, or in this case we already have the diameter, so I think I'll just do pi times the diameter, which is 12. So if I multiply that together, then I'm going to get 18.850 inches there. And for the large, I will only get 3 slices, so I have 3 out of 8. And then I'm going to do pi times the diameter, which is 14 there. And so if I multiply all that together in my calculator, I'm going to get 16.493 inches. So if all you care about is the crust because you really love the stuffed crust, then in this case you would prefer for them to purchase the medium pizzas. So very important thing for you to look at whenever you're ordering pizzas. All right. So let's just do a few more examples to make sure that we've got this down. So in example 6, I'm looking for the length of arc DC. That's indicated with the red right here in the picture. So if it's arc length, we need the fraction of the circle times the circumference. So in this case, my central angle is 100. That is out of a total of 360 degrees. And then I multiply by the circumference. In this case, since I have radius, I'm going to use 2 pi times radius. So 2 pi times my radius, which is 12. And so I'm just going to type all of that into my calculator. And I'm getting 20.94395. So if we round that to 3 places, it'll be 20.944 centimeters. There. The other part of this question asked me for the area of sector DAC. So DAC is going to be this area here. So it's still going to be 100 divided by 360, but this time it's going to be a fraction of our area. So I'll multiply that by pi times 12 squared. And so when I do that, I am going to get 125.663706. So that would be 125.664 if I round that to 3 decimal places. And that would be square centimeters because area is always measured in square units there. Okay. For the next one, I'm asked for the length of the blue arc. So this blue central angle here is 210 degrees. So I would need to do 210 out of 360. And since I'm looking at the arc, I want to multiply by circumference. In this case, that's 2 pi times 18. So I will just type that into the calculator. And whenever I do that, I'm getting 65.97344 and so on. So 65.973. This particular problem doesn't have units, so you don't really have to include those with your answer. Second part is just slightly trickier. It asked me for the area of the white sector, not the blue one where we already have the angle. But it's only slightly trickier. I just need to know what this central angle right here would be. So to find that, I will do 360 minus 210, and I will get 150 degrees. So this angle here should be 150 degrees. So to find the area of the white sector, I will do 150 divided by 360 times the area. So that is pi times that radius, which is 18 squared. So whenever I type that, into the calculator, I am getting 424.115008. So 424.115 square units, whatever type of units we might have there. Okay, we've got just a couple more to look at. The length of arc AC here, that would be the minor arc here because it's only named with 2 letters. In this case, would just need to be 150 divided by 360 times the circumference, which would be 2 times pi times the radius, which is 10 there. So if we type that in, typed it in wrong. We should get 26.179938, and that is going to be 26 point, this is a little bit of that tricky rounding right there. You got to round your 9 up to a 10, which is actually going to be 180, and that'll be inches there. Now, if I want the area of sector ABC, then I just need to do the same thing, but with my area formula. So I'll have pi times 10 squared. So if we type that into the calculator, we will get 130.89969. So that is going to be even trickier rounding. That's going to round up to 130.900 inches squared right there. We have to round that 9 up to a 10, which rounds the next 9 up to a 10, which rounds that 8 up to a 9. So that is what we'll get for example 8. And our last question here is probably our trickiest of all. It's a little bit of a backwards problem. The area of the shaded sector above is 4.5 square feet. What is the radius of the circle? So in this case, our area formula for the area of a sector is going to be theta over 360 times pi r squared. In this case, they gave us 4.5, which is the area. So 4.5 will go over here. My angle, I do know that that is 80, so I can plug it in here. And then I've got pi times the radius squared. Now this can be solved by hand. There's no big issue in doing that. You just need to get a number, divide, and take the square root. However, I feel like where we're at probably in this class, the way that most of you are going to approach this is to put f of x equals on the left side and g of x on the right side and use Desmos to see where this crosses. So let's do that here. So we would just type in f of x equals 4.5 and g of x equals 80 divided by 360 times pi times the radius, which we do not know, so we're going to have to call it x squared. And if I graph that, I have two options. There are two places where this crosses. However, it doesn't make any sense to have a negative radius. So that negative is not one that we want to use. Here we're getting 2.53885. We're going to round that to 2.539. So our radius is going to be 2.539. In this case, it would be feet there. So whenever you have a backwards problem like this, you want to set it up, and then you can use Desmos to solve it.